There are some rectangular prisms that we have specific names for. A rectangular prism is what we get when we're taking a rectangle and extruding it. So it's a prism with a rectangle for a base, for the two bases, I guess I should say. And you can go even further than that. A cube is what we get when we have all, you could, if this is our base and this is our base, if those are our two bases, then you can see the height of this particular prism is equal to the side length of the individual bases. And the bases, of course, would have to be squares. Another way of saying that is when we have squares for all 6 faces on this thing. Imagine a die, a 6-sided die. That is a cube. All right, a triangular prism is what we get when we take a triangle and extrude it out. I think the naming scheme here is pretty clear. A rectangular prism is what we get when we extrude a rectangle. A triangular prism is what we get when we extrude a triangle, or in other words, the bases are triangles. The orientation of this actually doesn't matter. You can see it in the examples so far, the bases have been the top and the bottom. But actually, it doesn't matter if your bases are on the bottom, on the left and the right. We would still consider those bases. The only consideration we'd have to have then is that the altitude would be the distance between the two bases. We can talk about other figures like a trapezoidal prism. That's what we get if we have a trapezoid for the two bases. And again, the orientation doesn't matter. We have a trapezoid here and a trapezoid here. The altitude is the distance between those. So you can imagine this is kind of going in that direction, versus this one is going up. This one is kind of going off to the right or off to the left. So when you're talking about prisms, if you recognize that it's a prism, once you recognize what your two bases are, you might want to make a note of that. It is worth noting with a rectangular prism, there's actually a number of different ways that you could choose your bases. So in this particular drawing, we have our bases here and here. The only reason I'm saying that is because we're specifically told, hey, this is a base. But normally with a rectangular prism, you have some flexibility. You could say this is my base, and this is my base, and then this would be my height. And it's just because of the nature of a rectangle, these end up being at 90 degrees. So it would still end up being a right prism. Most of the time it should be pretty clear based on what information is given which one you should call the base and the altitude. And if it's not clear, you're kind of free to choose. All right, so if we wanted to find, find the lateral surface area, the total surface area, and the volume of this triangular cross-section duct shown. So this looks like this is a triangular prism. It doesn't really matter that it's called that, but I do care. This is going to be a base, and this is going to be a base. And I am going to need, let me grab those formulas here. So first off, I'm trying to find the lateral surface area. And the formula for the lateral surface area of a right prism is perimeter times height. And the perimeter, since this is my base, this thing right here was my base, it has a distance, it says 6, 8, 10. Looks like it's a right triangle. And so the perimeter would end up being 6 plus 8 plus 10. I guess it doesn't really matter which order I do this in. 6 plus 8 plus 10, which is 24. So the perimeter is 24. It looks like all of these, it's a little blurry, but those appear to be in inches. So I'm going to call this 24 inches. So my perimeter is 24 inches. The height, this distance right here, the distance between my bases, is 15 inches. So my lateral surface area is 24 times 15, which is 24 times 15 gives me 360. 360, this would be a number of inches times a number of inches. The perimeter is a distance, thus it's in inches. The height is a distance, thus it's in inches. And you can see my lateral surface area ends up being a number of square inches. So 360 square inches here. That's part A. Part B, we're tasked with finding the total surface area. So this says the total surface area, which we're generally calling S, is going to be the lateral surface area plus the area of the two bases. We'll go 2a. Alright, so the total surface area plus the area of the two bases, that means, well, I already found my lateral surface area, that's 360. The area of my two bases, well, I'm going to have to come back here and say, well, this is a right triangle. I know that that's a 90-degree angle. So the area of each of the bases, which we're calling A, is going to be 1/2 times the base times the height. We actually need to use the fact that this is a 90-degree angle here. And let's call this our base. Now, I'm using the word base here in a couple of different senses. I'm using it to describe the base of the prism, that is the triangle. I'm also talking about the base of the triangle, that is this side. So, you know, hopefully it's not unclear. You know, whatever. I'm just reusing the same word. So we get 1/2 base times height. This 8 ends up being our height since this is measured at a 90-degree angle. Remember, normally when we're talking about a a triangle, we have to measure our height at a 90-degree angle to whatever we call our base. So multiplying these together, we get 24. That's kind of a coincidence. It's not the same 24 as we saw right there. In any case, we would get 360, that's the L we already found, plus 2. This is in square inches also, 2 times 24. Which gives us 360 plus 2 times 24 is 408 square inches. So I've added on the area of the two bases. Alright, so part C says find the volume of the triangular cross-section depth. So we're trying to find the volume of this now. The volume is going to be the area of the base times the height. And when I say the height here, I'm talking about the height of the prism, not the height of the triangle. Well, I already found the area. That was this stuff right here. That's 24 square inches. The height of the prism is 15 inches. And so we end up with a volume of 360 cubic inches. Now, the fact that I ended up with 360 square inches for the lateral surface area and 360 cubic inches for the volume, those are completely unrelated numbers. Don't feel like they have to be the same. They don't have to at all. This is just a pure coincidence because we're taking 24 times 15 on both of them. Remember, this is a distance times the distance. This was a number of square inches. This would be the amount of, if you were painting this, the amount of paint it would take to cover up the three lateral sides. That's what the lateral surface area is. If I was talking about the volume of this, that would be maybe the amount of air that this thing could hold. Clearly, that's not the same thing at all. All right, let's do another example. Let's find L, S, and V for the right trapezoidal prism shown. L means the lateral surface area. And in general, the lateral surface area of a right prism, it says it's a right prism here. It also says the bases are trapezoids. That's what the trapezoidal part is. But L is equal to perimeter times the height. So when looking at this, I need to decide what are my bases. I'm already told the bases must be trapezoids. And it looks like this is a trapezoid right here. Remember, a trapezoid has two sides that are parallel, and the other two are not. That's the base is right here. That's the trapezoidal. Let me change the colors because otherwise I'm doing black on black. It's kind of hard to see. So that's the one base there, and the other base would be back here on the other side of this. Maybe I should do this dashed. But that's the other base back here. So that means when we're trying to identify things, if our base looks like this, let me draw it over here. Actually, I'm going to switch back to black. The base of our prism looks like this. We have 4 feet. This distance right here, it looks like is 15 feet. It's not measured directly on this front face, but it is the same as this back one right here. That's how I know that this distance right here is 15 feet. This one is 12 feet, and then this one is 17 feet. Alright, so let's see, we're trying to find the perimeter of this guy, so it's just going to be the sum of those. Let's add those together. 4 plus 15 plus 12 plus 17 gives me 48. This would just be a number of feet. So I'm making a note here, P is 48. And the height, that's the distance between my two bases, that would be this distance right here, going that direction. And it looks like that's actually 10 feet, this distance, right, that measurement right there gives me the height of the prism. So my lateral surface area is 480 square feet, or square feet like this. Those are the two ways that we typically write square feet. Alright, so that's L. S is L plus the top plus the bottom, so L plus 2A. Well, I guess it's not top and bottom here, it's the left and, or the front and the back, maybe. I don't know. Whatever, the two bases. So I need to find the area of this trapezoid. And if you remember, or if you look up your formula for the area of a trapezoid, it is going to be 1/2 times, B plus B, B1 plus B2, however you want to call that. These are, so again, you know, we're reusing some letters in various formulas. And when we're talking about the height of our trapezoid, we're talking about the distance between the two parallel sides. In this figure, actually I guess I didn't copy it down, these two should be 90-degree angles. So this 15 is actually our height of the trapezoid, and this 4 feet and this 12 feet would be the two distances of my bases, because those are the two sides that are parallel to one another. Alright, so we get 1/2 times 4 plus 12, because those are my two bases of this trapezoid. The height of the trapezoid is 15. So let me go ahead and plug this stuff into the calculator. 0.5 times 16 times 15 gives me 120. And this would be, it looks like in square feet. Not that I need to write down the units of all these, but it's kind of, I don't know, I think it's worthwhile noting when we're talking about various different types of units. So the area of the trapezoid is 120 square feet. The lateral surface area is 480, so that means the total surface area is going to be 480 plus 2 times 120. 480 plus 2 times 120 gives me 720 square feet. And lastly, the volume of this trapezoid, my trapezoidal prism, is the area of the base times the height, and this is again the height of the height of the prism, not the height of the trapezoid. So this would be 120, and this right here was the height of the prism, that 10. So 120 times 10, which gives me 1,200 cubic feet. And since we have it in cubic feet, there are conversions you could do. You could figure out how many gallons that is. You can envision this as maybe this is a swimming pool. We have 15 feet in this direction, 10 feet in that direction. It's 4 feet deep in this side and 12 feet deep on that side. This would hold 1,200 cubic feet worth of water. So this is one case where you might need to know the volume of a trapezoidal prism.